Hey everybody. Today in lesson number 2 of area, we are going to get into finding the area of a few different figures. We did the parallelogram in the previous lesson. We did a triangle in a previous lesson. Now we're going to get into things like a trapezoid or a rhombus or a kite. And I first want to show you how to do it without any formulas or any shortcuts at all. And the reason I do it that way is because sometimes common sense is better than a formula. And on the end of course exam, these two formulas that we're going to be given later are not given to you. So if you can remember how to do it without the formula, you might be better off. So check out this line right here that I just drew on this trapezoid. Now this first figure, it is a trapezoid. It doesn't really look like one necessarily. Usually you think about something like the second one right here as a trapezoid. You don't always think about the first one like it, but it is. Remember, a trapezoid has one pair of parallel sides, but not two. Anyway, so if you look at that, to figure out the area of a trapezoid, one option that you have is to figure out the area of two separate figures. So you can say, well, I'm going to figure out the area of that green rectangle, and then I'm going to figure out the area of that red triangle, and then I'm going to add them together. And that's a great way of doing it. Even after I get done teaching the formula, I still have a lot of kids who do that. So if you have an 18 by 20 rectangle, length times width, base times height, whatever you want to call it, you end up getting 360 centimeters squared. Now, if you want to go back to the triangle over here, if the rectangle was 20, but this entire length was 24, then that tells you you have 4 extra that belong on that triangle. So you end up with an 18 by 4 triangle. Now remember, in a triangle, you do 1/2 base times height. So area would be 18 times 4, which is 72, but then you have to take half of that number, and half of 72 is 36. When you're done, you add those numbers together, and you get a total of 396 centimeters squared. All right. Now, on this next one, we would have to break it up into a couple of different pieces here. We would need a couple of different triangles to go along with it. Now, the difference between the top and the bottom, we had an 8, and then we have the whole thing is 14. The difference is 6. So we're going to have to break it up, and I'm going to break it up into 3 and 3. So that would be 3, 8, and 3. Now, some people might look at it and say, well, how do you know? You don't have any proof. It doesn't actually matter, as long as when you're going through, you break it up to where it adds up to the correct number, you'll get what you're looking for. So it didn't matter if I did 3 and 3 or if I would have done 4 and 2. It will come out exactly the same way, as long as the way I break up the triangles comes out to a total of 6. So you've got an 8 by 9 in the middle. That would be a rectangle, and you've got a total of 72 inches squared. That's not a squared symbol. All right, looks good to me. Then you've got a couple of 9 by 3 triangles. 9 times 3 is 27, but it is a triangle, so I want half of that. Half of 27 is 13.5 inches squared. The difference between this problem and the last one is there are now 2 of them. So if I wanted to do all of the area put together, I would get a 72 and a 13.5 and another 13.5. And when you add that up, you get an area of 99 square inches. Now, again, there is a formula for figuring out the area of a trapezoid, and we will get the same answer, but it's good to know how to do it without. Okay, take a look at the next one. You've got a rhombus right here. Now, I didn't mark it as a rhombus, but I promise you it is a rhombus. All 4 of those sides are the same, and the diagonals are perpendicular. Most of my students, even after I teach them the formula, they still prefer to break it up into 4 triangles, figure out the area of 1, and then multiply that number by 4. So even after we do today's formula, you're probably going to be like them, and you're probably going to do the same thing. Now, 3 times 5 is 15, but remember, if we're going to break it up into triangles, we're going to cut that number in half, because remember, if we're doing the area of a triangle, it's 1/2 base times height, so don't forget about that half. Half of 15 is 7.5, and then there are 4 of them. So if there are 4 of them, then you're going to have 7.5, but you're going to do that 4 times. That would be a total of 30, which means the area is 30 square feet. All right, one last one, and we're going to do it with a kite. Now, the kite one is a little bit tougher because these 4 triangles are going to be different. So we have a 7 by 6 triangle right here. 7 times 6 is 42. Half of 42 is 21. But then the one to the right of it is a 7 by 13. Now, 7 times 13 is 91. And then if we did half of that number, you would get 45.5. So you do the same thing on the other side. You've got another 21. And you've got another 45.5. And then you combine all of those numbers, and you end up getting, you add all those up, you get a 21, a 21, a 45.5, a 45.5, and you end up getting a total area of, that looks to me like 133 square meters. All right, now it's time to reveal the formulas and see if you actually like the formulas at all. Doesn't matter. If you like them, that's great. If you don't like them, that's great. Now, the area of a trapezoid is going to be 1/2 times the height times base 1 plus base 2. Now, what you're going to see here, these are subscripts. This little 1, this little 2, they are a subscript. Now, this formula is actually not as weird as you think it is, because if you add 2 numbers and then you cut that number in half, if you add and then divide by 2, you get an average. So really what's happening in the formula is you are averaging the 2 bases and then multiplying by the height. So you add those numbers up, you divide by 2, and then you multiply by the height. Now, the order doesn't matter when we multiply, and you'll see that here in a second, but I'm just kind of demonstrating that's what's going on here. So if you're wondering why the formula has a 1/2 in it, it's because we're taking the 2 bases, we're adding them, and we're cutting that number in half. It's an average. So if you look at that first example, it's 1/2 of 18, and then the 2 bases, remember the bases are just the 2 things that run side by side that are parallel. So even though in that picture that we had earlier, the trapezoid was sort of sideways from how you expected it, that doesn't change what the bases are. The bases are the 2 things that are running parallel to each other, the 20 and the 24. And that would give you that. Now you get the calculator out, and you do 0.5 times 18 times 20 plus 24, and you get an area of, you guessed it, 396, which is exactly what we had earlier. Okay, let's try that again here, just to make sure you kind of have the idea. We had 2 bases, one was 8, one was 14, and the height was 9. So let's try that out, and let's see if it works. Area equals 1/2 times the height times base 1 plus base 2. You throw that in the calculator. 0.5 times 9 times 8 plus 14, and you get, what do you know? 99 square inches, which is exactly what we had earlier. All right, now the formula for a rhombus or a kite is going to bring in a different idea. It's going to bring in something that you might not have known, and it's going to still have that 1/2 in it, but this time it's going to involve the 2 diagonals. It's going to be 1/2 D1 D2. Now, that D right there stands for diagonal, and it's not referring to just a little bit of the diagonal, it's referring to the entire thing. So if we are going to use the formula for this next example, and remember, we're just going to those examples from before and we're just working them out again to make sure the formula checks out. Don't use 5, use 10. Don't use 3, use 6. So if we're going to test out that formula, then we're going to get area equals 1/2 times 10 times 6. Half of 10 is 5. 5 times 6 is 30, and we get what we're looking for. Now, if you tried that again on the kite problem, now remember we had a kite problem. If we're going to use that formula, then we have to use the entire diagonal. So we don't want to use 7, we want to use 14. And then we don't want to use the 6 and the 13 separate, we want to use them together, and 6 plus 13 is 19. So again, when we use the formula, we're going to use 14 for one diagonal, and we're going to use 19 for the other one. So if you're going to use the formula, make sure you're using it right. So you're going to get area equals 1/2 times 14 times 19. Half of 14 is 7. 7 times 19 is 133 meters squared, which is exactly what we got up there. So I want to encourage you, you have the freedom. You have the freedom to either draw it out or you have the freedom to use a formula. And I don't really care what you do. Now, the only time it's really going to be complicated is when you don't have all the information you need. We're going to do 2 quick examples of when you don't have all the information you need. Like, for instance, if we're going to do a trapezoid, and I'll show you with the formula. The formula for a trapezoid looks like this. Now, whether you're doing the formula or whether you're breaking it down by hand, either way, the height is that. And if you're not really sure why the height is that, remember, this figure is really just turned on its side. If we turn it to the left, we get something like this. And that sort of reveals what we need. What we need is the height. They gave us the 2 bases. One was 15, one was 20. What we really need is the height. And so that's kind of obnoxious. What are we going to do about it? Well, we have to piece it together. If this is 15 and this entire base is 20, that means we had a leftover amount of 5. And now that we know that we had a right triangle, and we had a 5 and a 13, we can actually piece it together using the Pythagorean theorem. And that's something you've been practicing a bunch, so I won't spend a ton of time going over it because I think we know what we're doing. You end up subtracting 25 from both sides. You end up getting b squared equals 144. And that means b equals 12. So that 12 is actually the height that we needed. And now that we know that number, we can do the formula. So area equals 1/2 times the height times base 1 plus base 2. And again, if you don't want to do that, if you want to break it up into 2 pieces and then add the 2 pieces when you're done, I'm totally fine with that. It doesn't really matter to me. You end up getting an area of 210. In this case, it was 210 square yards. All right, last example of the day. We're going to deal with the rhombus here, and we have a 6, we have a 12, but we don't have any idea what's going on with that other diagonal. So we're going to have to do the Pythagorean theorem one more time. 6 squared plus b squared equals 12 squared. So you end up getting 36 plus b squared equals 144. And you subtract, and you end up getting b squared equals 108. Now, in the next lesson, we're going to learn a shortcut for this, but I actually think you might know it already. If you have to do the square root of 108, you have to figure out 2 numbers that go into 108, and one of them has to be a perfect square. So we're going to break it down into 2 numbers, and one of them has to be a perfect square. And it's always best to pick the biggest perfect square you can come up with, because then we can simplify quickly. So if we use 36 and 3, the square root of 36 is 6, and that means that missing length was 6 radical 3. Now you notice how we had a 6 here and a 6 radical 3 here? That's not a coincidence. Now in area lesson number 3, we're going to get into that a lot more. But anyway, if we do the area of just one triangle, and again, a lot of kids really like just doing the area of one triangle and then multiplying it by 4 when they're done. So I'm going to encourage you to do that. If we were to do that, we would get the area of one triangle. Half of 6 is 3. 3 times 6 is 18. And then radical 3. And then, because there are 4 of them, we're just going to multiply that number by 4. And we would get a total area of 72 radical 3 square inches. Now, if you don't like that, if you want to put it in decimal form, then you could just get your calculator out and you could just do 72 times the square root of 3, and you would get another answer, which is also accurate. There's nothing wrong with the other answer, just depending on how you want to write it, of 124.71 inches squared. So both of them are correct answers. It really is just a matter of how they ask you to write it. If you are told to write something as a simplified radical, then you would write it as the first format. If you were being told to write it differently or just round to 2 decimal places, then you would use the second answer. All right, I hope you see how this gives you the freedom to do things a couple of different ways. Do it however you want to do it. Just make sure you're careful about how to write your answers and your labels. Hope this helps a lot. I'll see you next time.